What if everything we know about human history is just the final chapter of a much longer story? What if the ruins we call ancient are merely the most recent in a cycle that has repeated for millions of years? Today, we explore a possibility that challenges every assumption about our place on this planet. We're about to journey into a hypothesis so profound, it rewrites the very meaning of civilization itself. Welcome to the Echoes of Forgotten Worlds. In 2019, a deep-sea mining expedition off the coast of Madagascar made a discovery that no one could explain. At a depth of 4,000 meters, where crushing pressure should preserve only the simplest geological formations, their sonar revealed something impossible. Perfectly geometric structures arranged in patterns that mimicked city grids. The mining company kept the discovery quiet, but leaked footage showed something that defied conventional explanation. Massive stone foundations arranged in concentric circles, connected by what appeared to be roads or channels, all buried under sediment that geological dating placed at over 12 million years old. 12 million years. That's 6 million years before the first hominids walked upright. Dr. Sarah Chen, the geologist who first analyzed the formations, describes what she saw. The precision was what struck me first. These weren't natural lava tubes or tectonic formations. The angles were too exact, the spacing too deliberate. And when we examined the rock composition, we found something that shouldn't exist. Traces of worked metal, corroded beyond recognition, but definitely processed. This discovery in the Indian Ocean represents just one piece of a puzzle that scientists have been quietly assembling for decades. A puzzle that suggests human beings are not Earth's first technological civilization, perhaps not even its second or third. The implications are staggering. If other advanced civilizations existed before us, why do we have no record of them? Where are their cities, their monuments, their bones? The answer may lie in understanding just how thoroughly time can erase even our most permanent achievements.
Imagine our civilization ended tomorrow. Every human being vanished in an instant. What would remain? Our greatest cities, New York, Tokyo, London, would crumble within centuries. Steel corrodes, concrete cracks. Within 10,000 years, the forests would reclaim everything. Within 100,000 years, erosion would reduce our skyscrapers to unrecognizable hills. Plastic, we think, would persist, but even plastic degrades under UV radiation and bacterial action. In deep ocean trenches or buried in sediment, it might last millions of years, but it would be microscopic fragments, nearly impossible to distinguish from natural polymers. What about our most permanent marks? Mount Rushmore would survive perhaps 7 million years before erosion wore the faces smooth. The pyramids of Giza might last 20 million years, but wind and sand would reduce them to shapeless mounds, indistinguishable from natural rock formations. And bones? Fossilization requires extraordinary circumstances. Less than 1% of all organisms that have ever lived become fossils. The odds of any individual human being fossilized are astronomically low. The odds of finding that fossil? Even lower. This is what geologists call deep time amnesia, the understanding that given enough time, the planet erases nearly everything. Dr. Michael Torres, a paleontologist specializing in taphonomy, the study of how organisms decay and fossilize, explains it this way. People don't grasp the scale. If an advanced civilization existed for even 50,000 years and then vanished 100 million years ago, we would find almost nothing. Maybe some chemical signatures in rock layers, maybe some weird isotope ratios that don't quite fit natural processes. But cities? Skeletons? Gone. Completely gone. This realization led to what scientists call the Anthropocene hypothesis. The idea that industrial civilizations leave distinctive markers in the geologic record, even if their physical structures don't survive. These markers include rapid shifts in atmospheric carbon dioxide levels, unusual concentrations of rare earth elements, synthetic chemical compounds that don't occur naturally, distinctive patterns in extinction rates. And when scientists began looking for these markers in Earth's ancient past, they found anomalies they couldn't explain.
Earth's geological record is written in stone, literally. Each layer of sedimentary rock captures a moment in planetary history, preserving chemical signatures of ancient atmospheres, oceans, and life forms. When geologists examine these layers, they find dramatic fluctuations in carbon isotope ratios, the proportion of different carbon types in ancient rocks. Most of these fluctuations have clear explanations: volcanic eruptions, asteroid impacts, the evolution of photosynthesis. But some don't fit. The Paleocene-Eocene thermal maximum, 56 million years ago, saw global temperatures spike by 5 to 8 degrees Celsius in less than 10,000 years. The carbon isotope signature suggests massive release of fossil carbon, as if someone burned through enormous reserves of coal and oil in a geological instant. Traditional explanations point to volcanic activity or methane release from warming oceans. But Dr. Elena Rodriguez, a geochemist studying the event, notes peculiarities. The carbon release shows pulsing patterns, rapid increases followed by brief stabilizations, then more increases. It's not the smooth curve you'd expect from volcanism. It looks more like consumption, like something was using carbon-based fuel in cycles. The Mediterranean basin contains even stranger evidence. Rock layers from 5.3 million years ago, during the Messinian event, when the Mediterranean Sea dried up, contain carbon signatures that some researchers describe as suspiciously organized. The carbon appears concentrated in specific geographic patterns that don't match known natural processes. It's as if someone was running large-scale operations in specific locations around the ancient Mediterranean. Energy production, maybe, manufacturing, something that required massive amounts of carbon combustion in very particular places. These carbon anomalies appear multiple times throughout Earth's history, always following similar patterns. Rapid increases in atmospheric carbon, sustained high levels for thousands of years, then sudden drops as if whatever was producing the carbon stopped. Each anomaly coincides with dramatic ecological changes, mass extinctions, rapid evolution of new species, fundamental shifts in ocean chemistry. The signature looks eerily similar to what human industrial activity is creating right now. But these events occurred when, according to all evidence, the most advanced life on Earth was primitive mammals and reptiles. Unless the evidence is wrong, or incomplete, or we're looking for the wrong things.
Everyone knows about the asteroid that killed the dinosaurs 66 million years ago. The evidence is clear. A thin layer of iridium-rich clay marking the boundary between the Cretaceous and Paleogene periods. Iridium is rare on Earth, but common in asteroids, so this layer provided smoking gun proof of the impact. But iridium appears in other geological layers too, places where no asteroid impact occurred. Some of these anomalies have natural explanations. Volcanic activity can bring iridium up from Earth's mantle, but others remain mysterious. Rock formations in Kazakhstan contain iridium concentrations in patterns that geologist Dr. James Wu describes as geometrically distributed. The iridium appears in regular intervals across hundreds of square kilometers, always at the same depth in the geological column, always in similar concentrations. Natural iridium deposition is messy, Wu explains. It follows volcanic vents or sediment distribution patterns, but this looks like a grid, like someone was extracting something from the ground in a systematic pattern, bringing up iridium in the process. The iridium appears in rock layers dating to approximately 47 million years ago, during the early Eocene epoch. At that time, Kazakhstan was covered with subtropical forests, populated by early horses, primitive primates, and crocodilians. Or so we thought. The iridium grid covers an area roughly the size of modern-day France. Underground radar surveys of the region reveal what some researchers call structural anomalies, cavities and channels in the bedrock that don't match known cave systems. These features run in straight lines for dozens of kilometers, intersecting at right angles, like a buried network. Mining tunnels, suggests Dr. Yuki Tanaka, a geophysicist who has studied the formations. That's what they look like. But of course, that's impossible. Nothing existed then that could dig organized tunnel systems. Certainly nothing that would leave iridium as a byproduct. Similar patterns appear in 6 other locations worldwide, all from the same time period, all showing the same geometric distribution of trace elements that shouldn't be there. In the Sahara Desert, scattered across thousands of square miles, lie fragments of yellow-green glass called Libyan desert glass. The glass formed approximately 29 million years ago when something, an asteroid or comet, generated temperatures exceeding 1700 degrees Celsius, melting the desert sand into glass. But the Sahara contains other glass deposits that don't fit the impact theory. In 2021, an archaeological expedition documenting ancient trade routes discovered glass formations that appear artificially structured. Unlike the scattered fragments of Libyan desert glass, these formations appear as fused layers, stratified like ancient roads or foundations, buried under millions of years of sand. Dr. Amara Okonkwo led the expedition. We were mapping Roman trade routes when ground-penetrating radar picked up these subsurface anomalies. At first, we thought they were natural mineral deposits, but when we excavated, the glass was arranged in layers, flat surfaces, perpendicular angles, and the formation depth suggested ages far older than any known civilization. Thermoluminescence dating placed the glass at approximately 15 million years old. Chemical analysis revealed temperatures exceeding 2,000 degrees Celsius, hotter than the Libyan impact glass, and showing sustained heating over long periods rather than a single impact event. Natural explanations fail, Okonkwo states carefully. Lightning strikes can create fulgurites, natural glass tubes, but not sustained flat surfaces. Volcanic activity can generate heat, but there's no volcanism in this region going back hundreds of millions of years. We're left with something that looks engineered, but predates any known engineer. The glass structures extend underground for kilometers, following patterns that suggest deliberate construction. Some researchers have proposed they might be foundations, all that remains of structures that once stood in this region when it was lush savanna rather than desert. But foundations built by what? By whom? 15 million years ago, the most advanced mammals were distant ancestors of modern species, none capable of constructing anything, let alone working with materials requiring 2,000-degree temperatures. The glass mystery deepens when examined at the molecular level. Trapped within the ancient glass are microscopic bubbles containing atmospheric samples from 15 million years ago. The gas composition shows oxygen levels slightly higher than today, but also traces of compounds that Dr. Chen Zhao, an atmospheric chemist, describes as incompatible with known natural processes. There are synthetic fluorocarbons, Zhao explains, in tiny quantities, but definitely there. These compounds don't exist in nature. They're industrial chemicals, but we're looking at samples from the Middle Miocene epoch, when supposedly nothing industrial could possibly exist.
The ocean hides Earth's deepest mysteries beneath miles of water. In 1997, the U.S. National Oceanic and Atmospheric Administration detected an ultra-low-frequency sound in the Pacific Ocean, dubbed the bloop. Initially mysterious, it was later attributed to ice calving in Antarctica. But the ocean holds other sounds that remain unexplained. In 2018, a hydrophone array deployed to monitor whale populations detected
detected regular acoustic patterns emanating from the Mariana Trench, the deepest point in Earth's oceans. These weren't natural sounds. They were too regular, too patterned. Dr. Sofia Petrov, the marine acoustician who first analyzed the recordings, describes them. Imagine a heartbeat, but slower, much slower. A pulse every 47 seconds, precisely 47 seconds. Not 46 seconds, not 48 seconds, exactly 47 seconds, repeating for hours. That kind of precision doesn't occur in nature. The sound originates from a depth of approximately 9,000 meters in a region where the seafloor is covered by sediment estimated at 200 million years old. That sediment should contain only the crushed remains of ancient marine organisms, slowly accumulating ooze from millions of years of oceanic life and death. But sonar mapping of the region revealed geometric anomalies buried deep beneath that sediment. Structures that reflect sound waves in patterns suggesting metal or dense artificial materials. The U.S. Navy, which maintains classified sonar arrays throughout the world's oceans, has reportedly detected similar acoustic signatures in 11 different deep ocean locations. All share the same characteristics: regular pulses, geometric source structures, and extreme depth. It's as if, Petrov says carefully, something down there is still operating, still powered, still functioning after unimaginable spans of time. Attempts to investigate further have been limited by the extreme difficulty of deep ocean exploration. Only 3 human-crewed vessels have ever reached the bottom of the Mariana Trench. Remote drones face crushing pressures that destroy all but the most robust equipment. But in 2023, a privately funded expedition managed to place a camera sled near one of the acoustic sources. The footage, later leaked online before being scrubbed, showed something that looked like rock formations, but with surfaces too smooth, too regular, and in one frame, enhanced and analyzed by independent researchers, what appeared to be symbols or markings eroded nearly beyond recognition, but suggesting deliberate inscription. The footage vanished from the internet within hours. The expedition organizers declined further comment. Official statements attributed the acoustic signatures to previously unknown geological processes. But Petrov and other researchers continue to monitor the sounds. They haven't stopped. They haven't changed. Every 47 seconds, something in the deepest darkness continues its ancient rhythm.
Antarctica, Earth's most inhospitable continent, holds secrets preserved beneath miles of ice. Ground-penetrating radar surveys conducted over the past 2 decades have mapped the buried landscape underneath the ice sheet, revealing mountains, valleys, and lakes that haven't seen sunlight for 34 million years. They've also revealed other things. In 2019, a joint research team from multiple universities detected massive underground voids in a region called Wilkes Land. These weren't natural caves. The void spaces showed geometric organization. Chambers connected by corridors, all buried under 3 kilometers of ice and bedrock. Dr. Henrik Larsson, a glaciologist on the expedition, describes the initial discovery. "We thought it was a data error. The radar returns showed structures too large and too regular. When we resurveyed with multiple systems, we got the same results. Something down there is hollow, something enormous." The structures extend across an area roughly 100 kilometers in diameter. Depth measurements place them at approximately 1,500 meters below current sea level, within bedrock that geological surveys date to 120 million years ago, the early Cretaceous period. Ice core samples from the region contain another mystery. Layers corresponding to periods when Antarctica was ice-free contain microscopic particles of refined metal, titanium, chromium, and rare earth elements in concentrations and purities that don't occur naturally. These particles look manufactured, states Dr. Lisa Zhang, a materials scientist who analyzed the samples. The crystal structures indicate controlled cooling from molten states.
The alloy compositions are optimized for strength and corrosion resistance. But we're looking at ice that trapped these particles 50 million years ago. Perhaps most intriguingly, electromagnetic surveys of the Wilkes Land structures detected faint but persistent magnetic signatures, suggesting power generation or energy storage on a massive scale. The magnetic patterns pulse, very slowly, one cycle every 6 hours, but the pattern is there. Something down there is generating or storing electromagnetic energy after millions of years. International treaties protect Antarctica from most exploratory drilling. The few deep drilling projects that have been permitted focus on climate research, not archaeological investigation. But leaked documents suggest that at least one government has conducted classified surveys of the Wilkes Land structures, using technologies not available to civilian researchers. The results of those surveys, if they exist, remain secret.
If advanced civilizations existed on Earth millions of years ago, one question haunts researchers. What happened to them? How do entire civilizations vanish so completely that nothing remains but ambiguous traces and unexplained anomalies? The answer may lie in the cyclical nature of Earth's climate and geology. Every 100,000 years, Earth undergoes dramatic climate oscillations driven by variations in orbital mechanics. Ice ages advance and retreat, sea levels rise and fall by hundreds of meters, and ecosystems transform completely. These cycles have repeated for millions of years. For a civilization dependent on specific climate conditions, these cycles would be catastrophic. Coastal cities would be submerged or stranded far inland. Agricultural zones would become deserts or ice sheets. The infrastructure of technological society would be repeatedly destroyed. Imagine if sea level dropped 120 meters tomorrow, suggests Dr. Marcus Webb, a climate scientist. Every coastal city on Earth would be useless. Ports stranded inland, water supplies disrupted. Now imagine it happening over just a few thousand years, fast enough that adaptation is difficult, slow enough that each generation tries to rebuild rather than relocate. That's what climate cycles do. But beyond these regular cycles, Earth experiences irregular catastrophes. Supervolcano eruptions occur roughly 100,000 years, each capable of triggering global climate cooling that lasts decades. Asteroid impacts, while rare, can devastate entire continents. The geological record shows multiple periods when Earth's climate underwent rapid, severe changes that would challenge even modern technological civilization. The Younger Dryas event, 12,800 years ago, saw global temperatures plunge by 15 degrees Celsius within decades, a change that occurred during the period when human civilization was first developing agriculture. We survived that event, Webb notes, but we were small, scattered, and pre-industrial. Imagine the same climate shift hitting modern civilization. Global agriculture would collapse. Billions would die. Our technological infrastructure might not survive. Now imagine such events occurring repeatedly over millions of years. Each time, civilizations might rise during warm, stable periods, only to be devastated when the climate shifted. Each time, survivors would be forced back to subsistence living, their knowledge lost, their cities abandoned to erosion and overgrowth. Over deep time, this pattern could repeat dozens or hundreds of times, and each time, the geological record would preserve less evidence as new sediments buried the ruins and tectonic activity ground them to dust. This pattern suggests something profound. Technological civilization might be more fragile than we realize. The stability we've enjoyed for the past 10,000 years, the stable climate that allowed agriculture and cities to develop, might be a rare exception rather than the rule. And if we're an exception, what happened during all those millions of years when conditions were nearly as stable? Were we really the only species to exploit those opportunities?
For life to develop, technological civilization requires specific traits.
intelligence, manual dexterity, social cooperation, and communication ability. Humans possess all four. But evolutionary biology suggests these traits aren't unique to our lineage. They've evolved multiple times in Earth's history. Cephalopods, octopuses, squids, and cuttlefish demonstrate remarkable intelligence despite having evolved nervous systems completely independently from vertebrates. They use tools, solve complex puzzles, and show individual personalities. Their ancestors have existed for 500 million years. Cetaceans, whales, and dolphins possess brains as complex as human brains, sophisticated communication systems, and rich social structures. Their ancestors returned to the ocean 50 million years ago, abandoning the land where tool use would be possible, but they retained and enhanced their intelligence. Crows and parrots demonstrate problem-solving abilities that rival primate intelligence. They use tools, understand abstract concepts, and pass knowledge between generations culturally rather than just genetically. Intelligence, explains Dr. Patricia Osei, an evolutionary neurobiologist, isn't a single peak that only humans climbed. It's a landscape with many peaks. Evolution has discovered intelligence again and again. The question isn't whether other lineages could develop intelligence. Clearly, they can. The question is whether any of them developed technology. Fossil evidence shows that several extinct species possessed unusual combinations of intelligence and dexterity. Troodon, a dinosaur that lived 75 million years ago, had a brain-to-body ratio comparable to modern birds. Forward-facing eyes suggesting depth perception, and grasping hands with opposable digits. Could Troodon have developed technology, Osei asks? The anatomical potential was there. Whether they actually did, we have no way of knowing. If they built things from wood and plant fibers, if they used stone tools, if they developed basic technology that didn't require metalworking, all of that would vanish completely over 75 million years. More intriguingly, some extinct mammals showed remarkable intelligence. Archaeotherium, an extinct pig-like mammal from 25 million years ago, had a large brain and lived in social groups. Smilodon, the saber-toothed cat, showed evidence of caring for disabled individuals, suggesting complex social bonds. The fossil record is so incomplete that we know details about less than 0.01% of species that have ever lived. We're looking at scattered snapshots of ancient life, missing entire chapters of evolutionary history. There could have been intelligent species, Osei concludes, that rose and fell in the gaps between our fossil finds. Species that lasted 10,000 years, developed sophisticated cultures, maybe even basic technology, and left no trace we can recognize. The absence of evidence isn't evidence of absence, it's just absence.
The Drake equation, developed to estimate the number of communicating civilizations in the galaxy, includes a factor rarely discussed: the longevity of technological civilizations. How long does a civilization remain detectable before it either destroys itself, transcends technology, or simply fades away? We assumed this applied only to alien civilizations, but what if it applies to us too, not as a future possibility, but as a recurring past? The universe is 13.8 billion years old, notes Dr. Robert Kim, an astrobiologist. Earth is 4.5 billion years old. Complex life has existed for 600 million years. That's an enormous amount of time. Technological civilization might not be a one-time event that happened with humans. It might be something that happens periodically, whenever conditions allow. The SETI program searches for radio signals from alien civilizations. But radio technology has only existed on Earth for 130 years, less than 1,000th of a percent of human history. If we're typical, Technological civilizations might use radio for only a brief window before moving to other communication methods. If another civilization existed on Earth even just 1 million years ago, Kim explains, they could have had radio, television, internet, everything we have and more, and we'd never know. Those signals would have been dissipated or been drowned out by natural cosmic noise. We're looking for something that might only be detectable for a geologic instant. The Fermi paradox asks why we haven't detected alien civilizations if the universe is so vast and old. But perhaps we're asking the wrong question. Perhaps the universe is full of civilizations, but they're separated by time rather than space. Perhaps the galaxy has been home to billions of technological species over its 13 billion-year history, each flourishing briefly before vanishing into deep time. And perhaps Earth itself has hosted dozens or hundreds of such civilizations over its long history. We only see evidence of the most recent, our own, because geologic time erases all but the faintest traces of what came before. It's humbling, Kim says quietly. We think we're unique, special, the first. But maybe we're just the latest iteration. Maybe intelligence and technology are things that happen to planets periodically, like seasons. They come, they flourish, they fade, and then, millions of years later, they come again. Our search for extraterrestrial intelligence operates under an assumption so fundamental that we rarely question it, that we would recognize an advanced civilization if we saw one. But this assumption may be our greatest blind spot. Dr. Yuki Tanaka, a theoretical physicist working on post-detection protocols for SETI, poses an uncomfortable question. What does a million-year-old civilization look like? A billion-year-old one? We're searching for civilizations that might be to us what we are to bacteria. And we're using our own technology, barely a century old, as the template. Consider what we're actually looking for. Radio signals, megastructures like Dyson spheres, atmospheric pollution, heat signatures. All of these assume civilizations remain recognizable, that they continue doing things in ways we can understand and detect. But human technology itself is becoming harder to detect. Our telecommunications are shifting from broadcasting radio waves into space to using fiber optics that keep signals contained. Our energy production is moving toward distributed solar rather than centralized combustion. Our computers are shrinking from room-sized machines to microscopic chips. There's a technological trajectory, Tanaka explains, from large and inefficient to small and efficient, from broadcast to point-to-point communication, from obvious to subtle. If you extrapolate that trajectory forward even just 1,000 years, human civilization might become nearly invisible to external observation. Now extend that trajectory millions of years. A truly advanced civilization might have technology that operates at quantum scales, or harnesses energy so efficiently it produces no waste heat, or manipulates space-time itself in ways that look like natural phenomena to less advanced observers. We might be surrounded by ancient technology, suggests Dr. Amelia Cross, a philosophy of science specializing in detection theory, and simply lack the conceptual framework to recognize it, like ants walking across a microchip, unable to distinguish it from an oddly flat rock. This problem isn't limited to space. It applies to time as well.
Every archaeological method has a detection horizon, a point in the past beyond which it becomes useless. Carbon dating only works back 50,000 years. Pottery survives a few thousand years at most. Even DNA degrades, becoming unreadable after millions of years except in extraordinary circumstances. Dr. Heinrich Müller, an archaeologist specializing in deep time preservation, describes the problem. We have excellent methods for studying human civilizations from the past 10,000 years, good methods for the past 100,000 years, poor methods for anything older, and essentially nothing that works reliably beyond 1 million years. This creates what Mueller calls the archaeological event horizon, a boundary in time beyond which civilizations could exist but remain fundamentally undetectable using current methods. Imagine an alien archaeologist arriving on Earth 100 million years from now. Could they detect that humans existed? Our cities will be gone, our plastics degraded, our nuclear waste decayed. What remains? The answer is troubling. Almost nothing recognizable as civilization. Perhaps some isotope anomalies in ice cores, if any ice still exists. Maybe some odd chemical signatures in rock layers. Possibly some fossilized bones, if we're extraordinarily lucky. And that's after just 100 million years, Mueller notes. Earth has had complex life for 600 million years. If civilizations existed 500 million years ago, we would have essentially zero chance of detecting them with conventional archaeology. This realization has led some researchers to develop what they call deep time archaeology, methods specifically designed to look for civilization signatures across geological timescales. These methods don't look for artifacts. Instead, they search for patterns, statistical anomalies in the distribution of elements, unusual isotope ratios, electromagnetic signatures in ancient rocks, even gravitational anomalies that might indicate large underground voids in unexpected configurations. Dr. Sarah Okonjo leads a team developing machine learning algorithms to scan geological data for such patterns. We're teaching AI to recognize what artificial patterns might look like in deep time, not looking for specific artifacts, but for anything that deviates from natural processes in ways that suggest organization, purpose, or design. The preliminary results have been unsettling. The algorithms flag dozens of anomalies in the geological record, patterns that don't quite fit natural explanations. Most are probably just gaps in our understanding of geology and chemistry, but some resist conventional interpretation. The algorithm doesn't know what it's looking at, it just identifies statistical outliers. But when the same types of outliers appear in multiple locations worldwide in the same geological layers, forming patterns that look organized, you start wondering.
The concept of the Great Filter emerged from attempts to solve the Fermi paradox. If life is common and the universe is vast and old, where is everyone? The Great Filter is whatever prevents civilizations from becoming visible across interstellar distances. The terrifying question is, where is the filter? Is it behind us, in the rare emergence of life, or intelligence, or technology? If so, we've already passed through it, and the galaxy might be ours to inherit. Or is it ahead of us, some universal danger that destroys all civilizations before they can expand beyond their home worlds? If so, our future may be terrifyingly short. Dr. Amanda Chen, a researcher studying civilizational collapse, suggests a third possibility. What if the Great Filter isn't a single event, but a recurring cycle? What if civilizations naturally rise and fall, never quite achieving permanent stability? And what if this cycle operates not just across space, but across time on individual worlds? This would mean Earth itself might be caught in a loop. Civilizations emerge during favorable periods, develop technology, expand, then collapse due to internal contradictions or external catastrophes. The planet resets. Millions of years pass. The cycle begins again. We see this pattern everywhere in nature, Chen explains. Predator-prey cycles, boom and bust ovulations, force succession patterns. Complex systems naturally oscillate rather than reaching stable equilibrium. Why would civilizations be different? The geological evidence, ambiguous as it is, could support this interpretation. Those carbon anomalies spaced millions of years apart, the iridium grids from different epochs, the deep ocean sounds that began no one knows when. Each could represent a previous iteration of the cycle. If this is true, Chen continues, her voice troubled, then the Fermi paradox has a darker answer. The universe is full of intelligent life, but intelligence is unstable. Civilizations bloom and fade like flowers, never lasting long enough to spread beyond their birth worlds, never achieving the permanence needed for interstellar contact. This wouldn't just apply to Earth. Every planet capable of supporting life might go through the same cycles. Intelligence emerging, reaching for the stars, then falling back into darkness, over and over across billions of years. The galaxy might be a graveyard not of dead civilizations, but of reset civilizations. Worlds that keep trying and failing to break free of gravity, not just physical gravity, but the gravity of their own limitations.
Perhaps the most profound implication of cyclical civilizations is what Dr. James Morrison, a cognitive archaeologist, calls the memory problem. Civilization is memory, Morrison explains. It's accumulated knowledge passed between generations. Writing, libraries, databases, these are all memory technologies. But what happens when civilization collapses? The memory dies with it. Human history provides sobering examples. We still can't fully read Linear A, the script of the Minoan civilization. The Library of Alexandria burned, taking countless ancient texts with it. Medieval Europe forgot how Romans made concrete, a technology not recovered for over 1,000 years. And those are just small disruptions, Morrison notes. Imagine a complete civilizational collapse. Imagine humanity reduced to scattered survivors without electricity, without industry, without even the ability to read the books in ruined libraries. Within a few generations, almost everything would be forgotten. The archaeological record suggests this has happened repeatedly in human history, on smaller scales. Complex societies have collapsed suddenly. The Maya, the Anasazi, Bronze Age civilizations around the Mediterranean, leaving their descendants with only myths and fragments of the previous sophistication. Now, extend this to geological timescales. Imagine a civilization that achieves our level of technology, then collapses. Survivors revert to hunting and gathering. 10,000 years pass, enough time for almost all physical traces to vanish. Do they remember? Do they have any idea their ancestors had cities, computers, aircraft? Probably not. The memories would degrade into myths, stories of ancient times when gods or giants built impossible things, stories that later generations would dismiss as fantasy. We have those myths, Morrison points out. Every culture has legends of advanced ancient civilizations, Atlantis, Lemuria, the antediluvian world. We treat these as pure mythology, but what if they're degraded memories? What if they're the last echoes of real civilizations, distorted beyond recognition by transmission across dark ages? This suggests something profound. We might have already discovered evidence of previous civilizations, but failed to recognize it because it comes wrapped in myth rather than in fossil and stone. Ancient texts describe flying machines, powerful weapons, advanced medicine. Hindu texts mention vimanas, flying palaces. Greek myths describe automatons built by Hephaestus. The Epic of Gilgamesh mentions the underwater home of Utnapishtim, who survived a great flood. Mainstream scholarship treats these as pure imagination, but Morrison asks, what if ancient peoples were describing real things they didn't understand? What if they encountered remnants of previous civilizations, found artifacts, saw ruins, and incorporated them into their mythology? The boundary between myth and history might be more porous than we think, and if civilizations left no memory except myth, then we should expect exactly what we see, a world covered in legends of lost advanced civilizations, but no hard evidence we can definitively point to. Because the evidence was already found thousands of years ago by people who lacked the framework to understand it.
and so transformed it into stories of gods and monsters instead.
If the cyclical hypothesis is correct, then we face an unsettling question. Which iteration are we? Dr. Lisa Kawamoto, a systems theorist studying long-term survival strategies, has attempted to model how many times technological civilization might have emerged on Earth. Her models incorporate variables like climate stability, biological evolution rates, and the frequency of planetary catastrophes. The numbers are necessarily speculative, Kawamoto admits, but the models consistently suggest that if technological civilization can emerge at all, it probably emerges multiple times. Earth has had stable, warm periods suitable for civilization development dozens of times over the past 600 million years, each lasting tens of thousands to hundreds of thousands of years. Her median estimate is sobering. If civilizations are possible, Earth might have hosted 15 to 40 previous technological societies over its history. We might be the 20th iteration, Kawamoto says, or the 30th. There's no way to know. But the idea that we're the first, that in 4.5 billion years intelligence and technology never happened until us, that seems increasingly implausible. This raises a crucial question. If previous civilizations existed and failed, why? What killed them? And are we doomed to repeat their mistakes? Climate change appears as a common thread. Almost every model collapse scenario involves civilizations inadvertently destabilizing their own climate through resource extraction and waste production. They prosper during stable periods, expand beyond sustainable limits, then face catastrophic environmental changes their technology can't solve. It's a classic overshoot scenario, Kawamoto explains. Intelligence and technology allow rapid exploitation of resources. This creates prosperity and population growth. But the exploitation destabilizes the systems that made prosperity possible. By the time the civilization realizes the danger, the damage is irreversible. Sound familiar? We're following the same pattern, Kawamoto says bluntly. Rapid technological growth, massive energy consumption, atmospheric changes, climate destabilization. If previous civilizations existed and failed, we're retracing their path with remarkable precision. But Kawamoto sees reasons for hope. We have something they might not have had, knowledge that we're not the first. If we take the possibility of previous civilizations seriously, we can study what might have destroyed them and actively choose different paths. The anomalies in the geological record, the carbon spikes, the extinction patterns, these might be warning signs left by civilizations that couldn't save themselves, but hoped their successors might learn from their mistakes. Every anomaly we find, Kawamoto suggests, might be a message, not an intentional message they probably didn't know we'd exist, but evidence that can teach us what to avoid, if we're wise enough to read it.
The evidence presented here is fragmentary, ambiguous, and controversial. Mainstream science remains skeptical of the ancient civilization hypothesis, attributing anomalies to natural processes we don't yet fully understand. But the questions remain. If we're not Earth's first technological civilization, what responsibility do we have to the pattern? Will we repeat the mistakes of our predecessors, whoever and whatever they were, or will we break the cycle? The carbon signatures, the underwater structures, the Antarctic enigmas, the acoustic pulses from the abyss, each could have natural explanations, or they could be echoes, messages, warnings. Perhaps the most profound implication of the ancient civilization hypothesis isn't about the past, it's about the future. If technological civilizations have risen and fallen multiple times in Earth's history, what does that say about our prospects? Are we doomed to repeat the cycle? Or can we learn from the silence that surrounds us, the absence of ancient voices, and choose a different path? Deep time has a lesson for us if we're willing to hear it. Nothing is permanent.
Civilizations that thought themselves eternal have vanished so completely that we can barely detect they existed. Their greatest works have turned to dust. Their knowledge has been forgotten. Their voices have faded to silence. But perhaps that's not the full story. Perhaps some of them survived, transformed, adapted, continuing in forms we don't recognize. Perhaps they're still here, watching us, waiting to see if we'll join them or follow the others into the fossil record. The choice is ours. The future is unwritten. But deep time is patient. It has seen civilizations rise and fall before. It will see us rise or fall as well. And millions of years from now, another species might stand where we stand, looking at the ambiguous traces we leave behind, wondering if they too are truly the first or merely the latest.